Hello and welcome to Lesson 2 of our Python track, Controlling the Flow. I'm Rishi, one of the heads of programming on Cardinalbotics. Today we'll learn about Booleans, comparison operators, Boolean operators, blocks of code, and most importantly, flow control statements which include if, else, elif, for, while, and break and continue. We'll also learn how to import modules. So, you know the basics of individual instructions and that a program is just a series of those instructions. But programming's real strength isn't just running one instruction after another like a weekend errand list. Based on how expressions evaluate, a program can decide to skip instructions, repeat them, or choose one of several instructions to run. In fact, you almost never want your programs to start from the first line of code and simply execute every line straight to the end. Flow control statements can decide which Python instructions to execute under which conditions. These flow control statements directly correspond to the symbols in a flowchart. So this is a flowchart, and to read a flowchart, you follow the arrows from start to end. So start, we go to this condition. Is it raining? Let's say it is raining. So then we go to, do we have an umbrella? Let's say we don't have an umbrella, so no. We wait a while, and after we wait a while, if it's still raining, then we follow the arrow back. We wait a while again. Is it still raining? No. So then we can go outside and that's the end. In a flowchart, there's usually more than one way to go from start to the end. So you can see in this flowchart, we could have just said, no, it wasn't raining, and then we'd be done. Or could we just said, yes, we do have an umbrella, and then we'd be done. The same is true for lines in a computer program. Flowcharts represent these branching points with diamonds, while the other steps are represented with rectangles. But before you learn about flow control statements, you need to learn how to represent these yes and no options in code. We need to also understand how to write these branching points as Python code. To that end, we have to explore Boolean values, comparison operators, and Boolean operators. Before I begin, I'd like to repeat that I really want you guys to try this stuff out at home. If you're new or relatively new to programming or Python, and you're just learning Python, it will help you a lot to try to type this stuff out in your own shell. So, while the integer, floating point, and string data types have an unlimited number of possible values, like integers can be any number, floating points can be any decimal number, and string data types can almost be any word or combination of letters and numbers. The Boolean data type, which is another data type in Python, only has two values, true and false. So here, I can try assigning the variable span to the value true. And you'll notice that mu highlights the value true because it recognizes it as a Boolean. Like any other values, Boolean values are used in expressions and can be stored in other variables. If you don't use the proper case, or you try to use true or false for variable names, Python will give you an error message. So we can't say lowercase true because it doesn't know what that is, and we can't name a variable true either. Comparison operators, also called relational operators, compare two values and evaluate down to a single Boolean value. This table lists the comparison operators. You've probably seen most of these in math. The first one, equal to, pretty obvious. Not equal to, obvious. Less than would mean if the value on the left is lower than the value on the right, etc., etc. These operators evaluate to true or false Boolean values, depending on the values you give them. So if we go back to mu here, let's try some operators. So we could say 5 equals 5. That's true, but 5 doesn't equal, say, 12. That's false. But if we say 3 doesn't equal 4, that's true because 3 doesn't equal 4. So that's a true statement. And if we say 3 doesn't equal 3, that's a false statement because 3 does equal 3. Similarly, we could say 5 is less than 10 because 5 is less than 10. But we can't say 10 is less than 5, but that will evaluate to to the Boolean value false. I'll try to go over a couple more examples pretty quickly. So for reference, on the left here is the table of all the Boolean operators. So we can see does 42 equal 42? True. What does 42 equals 99 evaluate to? False. 2 doesn't equal 3 evaluates to true. 2 doesn't equal 2 evaluates to false. Hello equals hello evaluates to true. Notice these two strings are actually different, so it will evaluate to false. Dog doesn't equal cat. This evaluates to true. Now we've done integer values, we've done string values, we can even use Boolean values for this. So true equals true, that's true. True doesn't equal false, this also evaluates to true. Now interestingly, Python is a little smart in that it can tell if the integer value of 42 is equal to the floating value of 42. But it can't tell if the integer value of 42 is equal to a string with characters 4 and 2. Now if we go to the relational ones over here, so 42 is less than 100, that's true, but 42 is greater than 100, this evaluates to false. Now 42 is less than 42, this also evaluates to false. Now, and you'll often use comparison operators to compare a variable's value to some other value, like here. So we set egg count equal to 42. Is egg count less than or equal to 42? Yes. It's equal to 42, so this evaluates to true. We can set my age to 29, which isn't my age, but might be the age of the author of the textbook. And what does this value to? My age is greater than or equal to 10. This evaluates to true as well. You probably noticed that we're using double equals instead of single equals. So the double operator equal to has two equal signs, while the single equal operator, which is the assignment operator, has just one equal sign. It's really easy to confuse these two operators with each other. Just remember these points. The double equal operator, the equal to operator, asks whether two values are the same as each other, while the single equal operator, which is the assignment operator, on the right into the variable on the left. A nice way to remember which is which is notice that the double equal to operator consists of two characters, just like the not equal to character, or not equal to operator, sorry, consists of two characters. The three Boolean operators and, or, and not are used to compare Boolean values. Like comparison operators, they evaluate these expressions down to a Boolean value. Let's explore these operators in detail, starting with the AND operator. So the AND operator evaluates an expression down to true if both Boolean values on either side are true. Otherwise, it evaluates to false. So try going into your own mu shell and enter some AND expressions like the ones you see on the right. A truth table, like the one on the left, shows every possible result of a Boolean operator. This table is the truth table for the AND operator. On the other hand, the OR operator evaluates an expression to true if either of the two Boolean values is true. If both are false, it evaluates to false. Again, make sure to try this out in the shell, and you can see every possible outcome of the OR operator in its truth table on the left. Unlike AND and OR, the NOT operator only operates on one Boolean value or expression. The NOT operator simply evaluates to the opposite Boolean value. So not true is false and not false is true. Much like using double negatives in speech and writing, you can nest not operators, but there's not really a reason to do that in regular programming. Recall that AND, OR, and NOT operators are called Boolean operators because they operate on Boolean values true and false. While expressions like 4 less than 5, which you see here, this is not a Boolean value. This is an expression which will evaluate down to a Boolean value. So here you can see 4 less than 5 evaluates to true, and 5 less than 6 evaluates to true, and then we can use the Boolean operator AND to see that it is true. To visualize it more, we can go through step by step by how this whole mess turns into true. So first, 2 plus 2 is evaluated to 4. 2 plus 2 is evaluated to 4. 2 times 2 is evaluated to 4. And 2 plus 2 is evaluated to 4. Then we check if 4 equals 4, and this evaluates to true. This here will evaluate to false, and this will also evaluate to true. Then not false evaluates to true. Then true and true, that's true. And then true and true, this evaluates to true as well. So if we go back to this flowchart here, flow control statements often start with a part called the condition and are always followed by a block of code. Before you learn about Python-specific flow control statements, we first have to cover what a condition and what a block is. So the Boolean expressions you've seen so far could all be considered conditions, which are the same thing as expressions. Condition is just a more specific name in the context of flow control statements. Conditions always evaluate down to a Boolean value, true or false. A flow control statement decides what to do based on whether the condition is true or false, such as, or like these diamonds do in the flow control statement. In the flowchart. Lines of Python code can be grouped together in blocks. You can tell where a block begins and ends from the indentation of lines of code. There are 3 rules for blocks. 1. Blocks begin when indentation increases. 2. Blocks can contain other blocks. And 3. Blocks end when the indentation decreases to 0 or containing blocks indentation. So let's break that down. Here's an example of code that is indented into blocks. The first block of code starts at the line print hello Mary, because you can see the indent. So I'll highlight that here. Inside this block is another block which only has a single line in it. You can see the indent. And then the third block is also only 1 line long. Note that these numbers aren't actually part of the code. Now let's explore the most important piece of flow control, the statements themselves. The statements represent the highlighted diamonds, and they are the actual decisions your program will make. The most common type of flow control statement is the if statement. An if statement's clause, that is the block following the if statement, will execute if the statement's condition is true. The clause is skipped if the condition is false. In plain English, an if statement could be read as, if this condition is true, execute the code in the clause. In Python, an if statement consists of the if keyword, a condition, a colon, and then starting on the next line, an indented block of code. For example, let's say that you have some code that checks to see whether someone's name is Alice. Pretend in this code that name was assigned some value earlier. All flow control statements end with a colon or followed by a new block of code. This if statement's clause is a block of code, print hi Alice. So if we were to use the flowchart analogy, we see, does name equal Alice? If this is true, then we print hi Alice. Otherwise, the program just ends. An if clause can optionally be followed by an else statement. The else clause is executed only when an if statement's condition is false. In plain English, an else statement could be read as, if this condition is true, execute this code, or else execute that code. An else statement doesn't have a condition, and in code, an else statement always consists of the following. 1, the else keyword, 2, a colon, and 3, starting on the next line, an indented block of code. So returning to this Alice example, we can use the else statement to make a case for if the person isn't Alice. So we start, if it's Alice, then print hi Alice, and then the code ends. But if it's false, if the name does not equal Alice, then we say print hello stranger, and then we end. While only one of the if or else clauses will execute, you may have a case where you want one of many possible clauses to execute. The elif statement is an else if statement that always follows an if or another elif statement. It provides another condition that is checked only if all the previous conditions were false. In code, an elif statement always consists of the following: 1, the elif keyword, 2, a condition, 3, a colon, and 4, starting on the next line, an indented block of code. So if we look at this code, this time, if the person isn't Alice and they're also younger than the age of 12, it prints, "You are not Alice, kiddo." Or if we look at here, so if the person is Alice, as usual, it prints "Hi Alice" and goes to the end. But if the person isn't Alice, it checks their age. And if their age is under 12, then it'll berate them for being a kid. But if they're over 12, then they're just ignored and the code ends. So let's try this yourself. Oh crap. Oh, cut me out. So here we've added 2 more elif statements to make the name checker greet a person with different answers based on age. So if the person is really old, then it'll print, "Unlike you, Alice is not a vampire." If the age is kind of old, then it will print, "You're not Alice, Granny." And like before, if the name is Alice, no matter what the age is, it'll say, "Hi Alice." But if the age is under 12, then it'll say, "You are not Alice, kiddo." Here's the flowchart for vampire.py. So first it checks if the name is Alice, and if it is, then it prints "Hi Alice" and the program ends. But if the name isn't Alice, then it checks if the age is under 12. And if the age is under 12, then it will print, you are not Alice, kiddo," and then the program ends. If the age is over 2000, then it will print, "Unlike you, Alice is not an undead immortal vampire." But if the age isn't over 2000, then if it's over 100, then it will print, "You're not Alice, Granny." But if it doesn't match any of these conditions, then it just won't print anything and end. The order of these elif statements does matter. So if we rearrange these statements, we can introduce a bug. So remember that elif clauses are automatically skipped once a true condition has been found. So if we swap around some of these clauses, we'll run into a problem. So type this out yourself or edit your vampire.py and save it as vampire2.py. So to demonstrate the bug, let's say we put in 3000 again. So last time, when we were 3000, it said, "Unlike you, Alice is not a vampire." But now if we run it, it'll say, "You are not Alice, Granny." This is because the age is over 100 condition is true, because 3000 is greater than 100, and the string "You are not Alice, Granny" is printed. The rest of the elif statements, in this case this one, is automatically skipped. So we have to remember that at most only one of the clauses will be executed. And for elif statements, order matters. So to fix this, we'd have to put this back down here. Here's the flowchart for the bugged code. You might have noticed that if the person's age didn't match any of the conditions in the last one, in the last examples, then the program just wouldn't say anything. So optionally, you can have an else statement after the last elif statement. In that case, it is guaranteed that at least one and only one of the clauses will be executed. If the conditions in every if and elif statement are false, then the else clause is executed. So in plain English, this type of flow control structure would be, if the first condition is true, which is if the name is Alice, if the first condition is true, do this. Else, if the second condition is true, if the age is less than 12, do that. Otherwise, do something else. So if the name is Alice, print "Hi Alice." Else, if the age is less than 12, print "You are not Alice." Otherwise, just do something else, which is you are neither Alice nor a little kid. And here's the flowchart for that. So you can see there's no error that goes directly to end here. You can make a block of code execute over and over again using a while statement. The code in a while clause will be executed as long as the while statement's condition is true. You can see that a while statement here looks similar to an if statement. The difference is how they behave. Here's the if statement that we had on the left. If we run it, we'll see it prints hello world once. This is because what happens is it checks if the condition is true, which it is because 0 is less than 5. It prints hello world, then spam is set equal to 1 because 0 plus 1 is 1. This is called incrementing spam, increasing it by 1. And then the program ends. But if we change this to while, you'll see there's a different behavior. It prints hello world 5 times. Now, why does it do this? This is because while will keep running this code while this condition is true, which is where the name comes from. While we'll keep running this code while this condition is true. So if we also print spam here, so we can see what's going on. Let's run it. So as you can see, each time while runs, or if I put this on top, it'll be easier to understand. So each time while runs, spam is increased by 1. So the first time it goes from 0 to 1, then it goes from 1 to 2, 2 to 3, 3 to 4, 4 to 5. But when spam equals 5, it prints it, and then it checks the condition, is 5 less than 5? No. So then the while loop ends, and then because there's nothing after, the program ends. Here's a small example program that will keep asking you to type literally your name. So if you type this code and save it as yourName.py, try running it and see what happens. So if we run it, it asks us to type our name, but it keeps asking us even if I keep typing it. Say I have to type Obama. No, because it literally wants us to type your name, because you can see right here, while name doesn't equal the string your name, it'll keep looping. But if we put in your name exactly, then it'll be satisfied and print thank you and then end the program. So let's go through this line by line. First, the program sets the name variable to an empty string. Then the condition checks if name doesn't equal your name, and obviously an empty string doesn't equal your name. So then we go to the next line, print please type your name, and then it takes an input which is assigned to the name variable. If the value in name is not equal to the string your name, this condition is true. So this block of code, these two lines, this block of code, the clause of the while statement runs again. And so it'll keep running this clause until the name equals your name. And we can see this here. So when it starts, obviously name doesn't equal your name. This statement is true because it's checking if name doesn't equal your name, and it's true, name doesn't equal your name. So we follow true, please type your name, name equals input. So we assign a new value to name, and then we check again. We check the condition again, name doesn't equal your name. Say I put in Rishi, then it's true. So it does the same again, it loops. You can see where the word loop comes from now. It's like looping around until the inputted name is literally the string your name, and then your name doesn't equal your name. Saying your name doesn't equal your name is a false statement. So it's false, so it prints thank you, and then the program ends. There's a shortcut to getting the program execution to break out of a while loops clause early. If the execution reaches a break statement, it immediately exits the while loops clause. In code, a break statement simply contains the break keyword, as you can see here. So the first line here creates an infinite loop, because while true, the condition is always going to be true, because true always evaluates to true. After the program execution enters the loop, this loop can only end, the program will only exit this loop when a break statement is executed, because this condition can never be false. So just like before, this program asks the user to enter your name. If the condition is true here, if name equals your name, if this is true, then the break statement is run and the while loop is exited from, and then it prints thank you. Otherwise, it goes back and does the loop again. Here's the flow chart. It looks a little more complicated than last time. So start, and the condition is automatically true, so we can never follow this arrow. So we'd start doing this loop, print, take the input, and the condition is here instead, because we have the if statement here. And if this if statement is true, then it runs the break, and it breaks out of the loop. You can see it breaking out of the loop. Otherwise, it continues looping around and around. So this is a situation you might run into yourself here. I've trapped my program into an infinite loop. The contents of the code isn't too important, but what's important is you notice I have a while true loop with no break statement. There's no way for me to get out of this. So am I just stuck here? Am I just trapped here? Well, no, there's two things I can do. One, I could click the stop button to stop the execution of my code. But a better method is to press Control-C, and I just press Control-C and it stops my code. Control-C it's not only used for stopping infinite loops. You can also terminate programs immediately. It works in almost anything. It'll work in your shell. It'll work in your terminal if you ever use that, etc. So yeah, Control-C to break yourself out of an infinite loop. So the while loop keeps looping while its condition is true, which is the reason for its name. But what if you want to execute a block of code only a certain number of times? You can do this with a for loop statement and the range function. In code, a for statement looks something like for I in range 5. Let's look at a for loop in action. So here I have a for loop. It says for I in range 5. Notice the I. Print Jimmy 5 times plus string I, and let's just see what it looks like. So it says Jimmy 5 times 0, Jimmy 5 times 1, all the way to Jimmy 5 times 4. So the first time it is run, the variable I is set to 0. The print call in the clause will print Jimmy 5 times 0 because I is 0. After Python finishes an iteration through all the code inside the for loops clause, in this case, just the print statement. But if you had more stuff here, then it would also do this line. After Python finishes an iteration through all the code in the for loops clause, the execution goes back to the top of the loop, and the for statement increments I by 1. So this was 0, and now it's 1. So you can see that here it becomes 1, and it runs it again, and then 2, it runs it again, 3, runs it again, and then 4, finally it runs it again. So the variable I will go up to, but will not include the integer passed to range. Here's the flowchart for the program we were just talking about. So first it prints, and then for I in range 5, and then it loops this 5 times, incrementing I by 1 each time. So I notice that this isn't really a condition. It's more like just it loops 5 times and then it's done looping. And you can actually do the same with a while loop. Here's the while loop version of our code, but as you can see, the for loop is a lot more concise. Some functions can be called with multiple arguments separated by a comma, and range is one of them. This lets you change the integer passed to range to follow any sequence of integers, including starting at a number other than 0. So on the left here, we're starting at 12 and ending at 16, but not going to 16. So you get 12, 13, 14, 15. Remember, it doesn't include the last number. The range function can also be called with 3 arguments. The first 2 arguments will be the start and stop values, and the third will be the step argument. The step argument is the amount that the variable is increased by after each iteration. So on the right, we have for I in range 0, 10, 2. So it'll step by 2 instead of 1, which is the default. So you can see it goes 0 to 2, 4, 6, 8. And it goes up to, but not including 10. So 0, 2, 4, 6, 8. So the step argument can also be negative. So take a moment to figure out what this might be, or what this might print. And here's the answer. So before we continue, we have to talk briefly about modules. All Python programs can call a basic set of functions called built-in functions, which are like print, input, len, all the stuff that we've been using, range. Python also comes with a set of modules called the standard library. Each module is a Python program that contains a related group of functions that you can use in your own programs. For example, the math module has functions related to math, and the random module has functions related to making and using random numbers, and so on. We're using the random module. So first we have to import the module with an import statement. So this allows us to use the module's code in our own code. And then here we're using the module. So we do random because that's what we imported it as, random.randint, which is the function that we're using. In this case, randint gives us a random integer between these two values. So the output will look like this because it's a random integer between 1 and 10, 5 times. We're going to write another short program today to put together all the material we've gone over so far in today's lesson. We'll do this by making a guess the number sort of game. Here's what the goal should look like. So the computer says, I am thinking of a number between 1 and 20. Take a guess. We guess 10. It tells us our guess is too low. Take a guess. 15 too low. 17 too high. And then we guess 16, and it tells us how many guesses we guessed it in. So using all the flow control we've learned today, we'll be able to make a program like this. So this is the code for the game. Try to type this out into your own editor and save it as guessTheNumber.py. And if you have any errors, first try to see what line number the error is on and try to fix it. If you can't figure out, feel free to message me, Rishi on Slack. But you don't have to copy, obviously you don't have to copy the comments exactly or the words in the string, because that won't actually affect the execution of the program. Alright, let's see what happens when we run this. So it says, I'm thinking of a number between 1 and 20. We'll start with the middle. That's too low, so we'll go up. Oh, 2 guesses. Well, that was a little faster than I was expecting. Now we can try again. 1 and 20. Too low. That's also too low. So notice it's not 15 anymore. It's a new number. Maybe 18. 3 guesses. Also, it won't let us go past 6 guesses. So if I do bad guesses each time. Yep. So it says nope. The number I think I was 20. Funny, I was guessing 1. And it only let us guess 6 times. 1, 2, 3, 4, 5, 6. So let's quickly explain what's going on here. So obviously this comment explains what the program is doing. First we import the random module so we can use it to create the secret number. So this makes a number between 1 and 20. And it's secret. Then we tell the user. And we store the secret number in the variable called secret number. So here we give the player 6 chances to guess it, because it will, for range 1 through 7, 7 minus 1 is 6. That's 6 chances. This will loop 6 times. So first it will ask the player to take a guess and wait for the input. If the guess is less than the secret number, it prints your guess is too low. If the guess is greater than the secret number, it prints the guess is too high. Else, that means if it's not too low or too high, which means the guess, this would be the same as saying else if the guess equals the secret number. But we can just say else because there's no other place for the number to be. We break this loop and we automatically go to here. So for the final if statement, there's basically 2 ways we can get here. One, we could have just ran out of guesses, and then in that case our guess would not equal the secret number, so it'd say nope. And if we broke it instead, this would be if the guess equaled the secret number, so this would be true, and it would print good job. And then this guess is taken is the variable here, which gets incremented by 1 each time by the for loop, so it is the amount of guesses that we've taken. That's why it starts at 1 instead of 0. Here's another program. This one is for the classic game rock, paper, scissors. This example is going to be pretty lengthy, so I don't really expect you to type this all out at home. but it's going to be very, very similar to this week's practice problem. So I'll include like a pastebin link or something in the description of the video where you can copy and paste it into your editor to play around with it. And I'll also be linking the slides in the textbook in the description as always, and you can look for it there. This is going to be a game of rock, paper, scissors, and let's just play to see what it does. So first it says rock, paper, scissors, and we have to enter remove rock, paper, scissors, or quit. So I don't know, rock. All right, I won. Natural born rock, paper, scissors player. Let's keep one with rock. Oh, we lost already. Look at that. And notice it's keeping track of our wins, losses, and ties. Maybe let's try to get a tie. I'll go scissors. All right, there we go. This isn't scripted, I swear. So 1 win, 1 loss, 1 tie. And interestingly, this program is infinite. And what I mean by that is the previous program would only run 6 times before telling us that we lost, but here we can keep playing. So I can spam rock a little bit, and you can see my wins, losses, and ties going up. Looks like I win a lot more than I lose. What can I say? I'm just really, oh, never mind, I jinxed it. But as you can see, I can keep playing, and I can also choose to quit at any time. So we press Q, and it will exit. So let's go through this code chunk by chunk, and as I said, this is going to be very similar to the practice problem. So first we import the random and sys modules. Notice how we can import 2 modules in the same line. So for the random module, we use the random number generator that we've seen before. The sys module we haven't seen yet, but it's pretty simple. We can just use the exit function to quit the program. And then we print rock, paper, scissors. Then we declare our 3 variables, or sorry, we initialize our 3 variables. Wins, losses, and ties. We initialize our 3 variables to keep track of the number of wins, losses, and ties. So this program uses a while loop inside of another while loop. I can't really show the whole thing here, but this first while loop is the main game loop. A single game of rock, paper, scissors where we say rock, paper, or scissors, and then it tells us if we won or not, is 1 iteration of this entire loop. This is the game loop. The second loop here, it's pretty small. This one asks for input for the player, and it keeps looping until we give it proper input. So what I mean by that is this. If we don't give it R, P, S, or Q, say I give it like, hello, goodbye, it doesn't let us put anything in, right? Unless we put in scissors, and then it'll be satisfied. So this in itself, it's also a while loop. So first it asks us to enter R, P, S, or Q, and if it's Q, then it exits the program. If it's R, P, or S, then it breaks this small while loop so it can go on to the rest of the code. If it manages to get to this line, that means it wasn't Q, because if it was Q, it would have exited the program. And if it was R, P, or S, then it would have broken out of the while loop. So the fact that the program got to this line means the user didn't put R, P, S, or Q. So because the condition is true, it goes through again, and it'll keep looping this until the player puts in a proper input. So here, this is pretty simple. This will just display what the player chose. So if the player chose R, it'll print rock versus etc. So next, the computer's move is randomly generated. So since random.randint can only return a random number, the 1, 2, 3 integer value is stored in the variable called random number. So this can be 1, 2, or 3. We assign the computer move rock, paper, or scissors, and we print that out. Finally, in this long if and else if chain that we have here, the program compares the strings in player move, which remember we assigned back here, it's the player input. It compares player move to computer move, which is assigned here with the random number. and then it displays the result on the screen. So there's a case for every combination here, which might not be the most efficient way to do it, but it's the easiest to understand. So first, if player move is the same as the computer move, then it's a tie. If the player move is R and the computer move is S, then rock beats scissors, so the player wins, and etc. You can see there's a case for each one. And then if the player wins, then it increments wins by 1. If the player ties, then it increments ties by 1. And if the player loses, well, you can probably guess. And then once this is done, there's no more code after this. I can't scroll down. So it goes back to the top of the while loop. And because the condition is true, it'll run again. It'll print the amount of wins, losses, and ties. So this will print however many wins, however many losses, and however many ties. And then it'll just keep looping and looping. So in summary, Booleans are a data type that can only have the value true or false, unlike integers or floats, which can be almost any number. Expressions that evaluate to these Booleans are called conditions, and by using conditions, we can write programs that make decisions on what code to execute and what code to skip. And these decision-making statements consist of if, else, else if, which is written as elif, for, and while, which are loops. And then you can also use break, statements like break, to help us in our flow control. All right, so for this week's practice programming problem, this one's going to be a little more involved than the last one. So I want you to write a program that has the user bet if a coin will land on heads or tails. The user should start with some money, and they should make money if they make the right guess. So here's the example I have. Heads or tails, we start off with $5, and then it asks us to enter our move. Bet heads, bet tails, or quit. We bet heads, asks us how much money we'd like to bet. We bet $3. It landed tails, so we lose our $3, and we now have $2. Then we can bet again. I bet tails this time, and I bet $2, all my money, $2, and it lands on tails, so I double my bet, and now I have $4. Here I've highlighted the user inputs if this makes it a little easier to understand what's going on here. If you still have any questions, feel free to contact me. Some things to keep in mind when you're making this. Only allow the player to choose to bet heads, tails, or quit. So here I put in some nonsense, like nonsense response, blah. And so the computer reminds me only type heads, tails, or quit. And a bonus thing you can do is don't let the player play if they have less than $0 here. I lost all my money, and it makes me stop playing automatically.